formulation of LPP, all of them, they are going to be transformed, they're going to be changed into graphical method. But there is a condition which is required for having the graphical method, okay? For solving the problem into graphical method, there are certain things which are required, all right? So in a graphical method, it's nothing but 1 minute. I just want to check if it is the same PPT which I'm sharing with you. Wait. Okay, it's same. Okay, it's good. Okay, fine. All right. So in a graphical solution to RPP, to this RPP or linear programming problems, whatever things which I have done in formulation, you remember we did the formulation of RPP, okay? Formulation of RPP is going to be, we are going to put them into graphical method. We are going to put into graphics, means to the graphics or to the two lines, vertical line and the horizontal line. The vertical line will be x2, the horizontal line will be x1. Okay, so we are going to plot, we are going to put every data which we have seen, such as the constraint data. This is introduction, such as our constraint, the constraint which we have made, the constraint data. Okay, the constraints, as well as so-called the objective function, our objective function. All right, the objective function also is going to be plotted here. Sorry, objective function is going to be plotted on this diagram, on this graph. Objective function is also to be plotted on the same, or they're going to be on this graph. Okay, they're going to be on this graph. Now, coming to this one, what does it mean, graphical LPP? Graphical LPP solution is a method used to solve a problem with two variables only, period. Underline that one, all right? This graphical method is what? It is a graphical method. Solution is a method used to solve a problem with how many? Only two variables. Beyond two variables, we don't need to use the graphical method. There are so many methods to find, remember. So this one, all these things, what we need to do, we want to find two objectives. We want to find one of the objective. It can be the maximum, okay? It can be the maximum, or it can be the minimum, okay? Or it can be the minimum. So the objective function, which we have formulated, okay, based on our problems, they are going to be plotted, they're going to be put on the graphical, so that we can find what is the maximum, we can find what is the maximum, and we can find what is the minimum. So these are the following steps which you have to go along with. Step number one, you have to consider each inequality constraint as equation. Right, what does it mean, inequality? When we say inequality, okay, when we say inequality, as you can see that that word which is there, the inequality, sorry, this is not providing what I need. Okay, so when we say inequality, okay, when we say the inequality, this inequality means quantity. The inequality, we mean a quantity, with different, okay, with a different values, with a different values. So the quantity with the different values is known as inequality. This is underline one, inequality. This one, it's inequality. All right. Example. We can give some example. What should be the example? The symbols, we have some symbols for this one. The symbol used, okay, the symbol which we use here, the symbol used, the symbol used here, we use greater, okay, we use lesser, greater than, lesser than equal, or greater than equal, or opposite of them. Okay, these are the symbol which we use for the inequality equation. Inequality equation means what? Quantity with different values. Symbol used are this one, are this four. All right, so these are the symbol which we use. All right, so this symbol example, you can give an example for this one. We can say here example. We can take an example of this inequality. Example. Okay, example, when you say like x plus, when you say x plus 1, it's lesser than, should be lesser than let's say 20, no problem. All right, or when you say x is greater or equal to, should be greater or equal to 0. These are known as inequality. These are known as what? These are known as inequality equation. For equality equation, when we talk of equality equations, for the equality equations is a quantity, you can write down, equality equation is a quantity, equality equations are the quantity with, okay, quantity with what? With the same value, with the same value. Example, I will write example, sorry. I will write some example there, okay? I will write some of the example. I will write some of the example there, all right? We can take example of, we can have like example of what? Of equality equations. Example, when you take x plus 1 is equal to 10, or when we say 2 plus 3 is equal to 5. So these are known as what? These are known as equality equation. Okay, this is equality equation. So symbol used, the symbol which we use here, we use equal sign. Okay, we use this equal sign. Whereas in inequality, for inequality, we use lesser or equal to, we use a lesser or lesser equal to, greater or equal to, or greater, or we use the difference. This is for inequality. Okay, inequality. Okay, inequality. All right, so this is the first line which we have seen there. All right, these are the first line which we have seen for the first one, for the first step. We have to consider each inequality constraints as equation. That's step number 1. Step number 2, plot each equation on the graph, as each one will geometrically represent a straight line. All right, each one will represent a straight line. How each one will represent a straight line, we shall see. Okay, how we will plot each one on our plot. We draw each one on our plot. Okay, the constraint will be on the coordinates. They will be on the coordinate. We shall see them. This will be x. This will be x2. This will be x1. Okay. Let's say first constraint will be like this line. That's the second step. We shall see them. Okay. And that's the second step. Step number 3. Every point on the line will satisfy the equation of the line. Now, this is important. Please note it. This is very important. Note it. If I'm going to underline, if constraint correspond to that line is lesser or equal to then the region below the line lying in the first quadrant is shared. What does it mean? What does it mean? We mean like this. We mean like this way. Let me bring it here. We mean like this way, okay? We mean this. For the second step, please go step by step, and then we shall understand how these stuffs are being used, okay? Okay? We go step by step, all right? What do we mean? We mean that the plot, let's say constraint, let's say we have a constraint which is equal to, let's say, x1 plus x2, okay, should be lesser or equal to 2. All right? So this is a constraint, correct? This is what? This is a constraint, okay? Now, if we plot like this one, this is a first constraint. Let's say this is a first constraint, this is a first constraint. Now, if we plot, for example, we have like this line. Since the sign, remember, we are on point number 3. We are on this point. Let me bring these 2 points here. Okay, let me bring these 2 points here so you can understand them better. Okay, we are where? We are on this point. Please consider. This is a point number 1. Point number 1. This is point number 2. Point number 2. All right? If inequality constraint correspond to the greater, it has gone, okay, correspond to the greater, lesser or equal to, then the region below the line in the first quadrant is shared. Means here, if we come to this one, okay, if we come to this one, what do we do? This line is going to be shared, all right? The line to be shared is going to be below the line. This is below the line, below the line, below the line. Why? Because of what? Because the sign which we have here, inequality, is lesser or equal to. Second point. For inequality constraint is greater than, okay, or equal, the region above the line is above the line in the first quadrant is shared. You get it? Now here we have one more point to consider. Okay, one more point to consider. Let's take another constraint. If we have x1 plus 2x2, okay, it should be greater than, let's say, 10. It's an example. Now, since the sign is greater than, now let's plot this line. Let's say the second line is this way. Let me put like this example. This is a second line. This is line 1. Line 1. This is, let me use a red ink. This is line 1. Okay. And this is line 2. This is line 2. This is line 2. All right. So now the second question says that this, remember, when we are dealing with the minimum, remember, this is for the minimum cost. Minimum cost. This is for the minimum cost. This is for the maximum. Remember, for the constraint, for the maximum cost. Okay, for the maximum. All right. For the minimum cost, if we come to happen, we have this sign. Now, which is going to be shared? The above the line, this way, this way, this way, this way, is going to be shared. Okay, not under the line, not under the line. That is the second point from our step number 3. You get it? So these are now the point lying in a common region will satisfy all the constraints simultaneously. Means if we have like a 2 constraint, it's a very difficult we can have the same way. We can have like this constraint. Look at this one. You may have like a first constraint. You may even have the second constraint like this. It can be possible. Yes, it can be possible. Okay. If we have them, then when you plot them, they will be like this way. For the maximum above the line, it will be above the line. For the minimum will be below the line. For the minimum will be below the line. Even I can shade like this, below the line. For the minimum, okay, below the line, below the line, below the line. All right, that's point number 3. Now, step number 4. Choose a convenient value for z. Say z is equal to 0 and plot objective function line. Now, if we look to the example, we shall look to the example, all right? We shall look to the examples. Let's consider this like, let's say max is example, right? Maximum z is equal to 2x1 plus 3x2, okay? Subject to constraint, we have the subject to constraint, subject to which constraint? To x1 is an example, plus x2, okay, x2 lesser than 2, okay, again 2x1 plus 3x2, okay, lesser than 4. Okay, now we want to find also the coordinate for this max z, means the maximum z. We have also to plot it on our line. Let's take an example. We will plot this one after understanding point number 4. After understanding point number 5. Okay, how it's going to be substituted, all right? So z is going to be equal to point number 4, step number 4, it says, choose a convenient value for z. Say z is equal to 0. Look to this example which we have here. Max z 2x plus 2x1 plus 3x2. Let me write it here. Max z, let's say z, we are given z is equal to 2x1 plus 3x2. Okay, now to the step number 4, let's say z is equal to 0. What does it mean? We mean 2x1 plus 3x2 should be equal to 0. So we make it as an equality question. Okay, we form as an equality question. So now we start to solve. Okay, we solve this one, we find the value of this one. Okay, that's step number 4. Step number 5, put the objective function line to the extreme point of feasible region. What does it mean, feasible region? Feasible region are these which are shaded. Remember, this region which I have shaded here. Okay, this region which I have shaded, this region which are shaded, they are known as a feasible region. These region which are here, these are feasible. These are the region. Okay, it will be feasible if the two lines, this line which you see here, let me also use red ink, and this one, they have the common region. That will be a feasible region. Okay, so that's known as a point number 5. In the maximization case, the line will stop further from the region. This is, if you understood this one, how maximization works. The maximization, the region is going to be below the line. The shade is going to be below the line. For this maximization, okay? For minimization or to the greater than sign, the line is going to be above the line. Clear? That's point number 5. Point number 6, read the coordinate of the extreme points. Select in step number 5 and find the maximum or minimum value. All these, they are the steps which we are going to work so that we can solve a problem. Clear? Now, here we have a question, a problem. So this is a problem which we have, and we are going to construct this problem on our graphical method. Before I plot or I solve this question, is there anyone who has a problem? Is there anyone who has a problem? Is there anyone has a problem? Any doubt? Anyone has a problem? Is it clear? If it is clear, yes, please.
Sir, I have one doubt.
Yes, please. Surya, go ahead.
Sir, we are passing some line now, sir, in
Hmm?
X and Y axis, one line.
Sorry?
We are passing one line now, sir, on X and Y axis. How
Yes,
can we do that?
when they are passing.
Sir, can you hear me?
Yes, I can hear you. Yes, go ahead, Surya.
When we pass a line on X
Yes.
and Y axis, you showed no, sir. How will we pass that?
You mean when I pass line in the which example? Let me take an example here. Let me come to this board. Okay, Surya, this is a
Yeah,
this is
sir.
this is this is which line is this one? You are called. You want this to be y. Sorry,
Mm.
you want this to be y. Okay, you want
Okay.
this to be y. You want to call this as a y, and you want to call this as a x. Huh? Yes. And let's say
Okay,
we have a, let's say we have a line. Let's say here is a 6.
that
Let's say
is the
here
line, sir. How will
is
we
a 5.
pass that?
Huh? Hmm?
How can we pass that? That is the line. Why we pass that?
This line.
Yeah.
Yeah, I will show you. I will explain. This is the next step. We are going to see how this line can be drawn. Okay?
Okay,
The second.
sir.
Yeah, the second. Yeah. Yeah, don't worry. We are going to see how this line is going to. I use this one to explain how we are going to do for step by step, so you can understand every step how it works. So now we come to solve this problem, then you will be able to understand how this line are going to be drawn. Okay? Is there anyone has a doubt? Feel free. Is there anyone has a doubt for all steps? Step number 1, step number 2, step number 3. And why do we need the graphical solution? We need it to solve LPP, which has how many? Only 2 variables. Variables, I forgot to tell. The variables is x1, okay, and x2. Or you may have x and y, 2 only. If you have x1, comma, x2, comma, x3, this type you cannot use graphical method. You cannot use graphical method is not applicable. This graphical method for this one, I put x is not applicable. For these two steps which we have here, it's applicable. Okay, we can do. More than 2 variables, you cannot use graphical method. All right, so there we
Uh,
go. Yes, please.
and sir, excuse me.
Yes,
And
please.
what if the straight it doesn't
Hmm?
have a straight line? What if it doesn't have a straight line?
It has
If
to
it
have a straight line. It has to have a straight line because the coordinate which you are going to formulate, for example here, this, if we solve this question, you understand. Okay, if we solve this problem, you understand. Because a straight line, we mean the straight line we are going to form, we want to form the points. Let me call them like a points. Okay, we want to form the points for all the constraints. This is constraint 1 and this constraint 2. So the point we should start from 0, okay, and above and goes ahead. All right. So there is no point of not having a straight line. You mean that is known as a continuous, Ashish. To have a continuous, for example, you mean a graph which goes like this, like this, like this. This type, we are not going to deal with it, okay? We are dealing with a straight line. This is known as a straight line, okay? Without any passing here and there, a continuous line, okay? Without a continuous line. So we are not going to deal with these lines which goes like this one. I think this is what you wanted to ask. Is it correct? Yes, Ashish?
yes, sir.
Yeah, such kind we are not going to deal with them. Okay? We are not going to deal with this one. So what we are going to deal with is for the straight line. Please hold on as we solve this question and then you will understand. There we go. I hope the steps are clear. If they are not clear, don't worry, this question is going to solve it. Okay, now here we have the problem. Okay, we have the maximum z which is equal to 12x1 and 16x2 plus 16x2, subject to the constraint 10x1 plus 20x2, which is lesser or equal to 120. First constraint. Second constraint is 8x1 plus 8x2, which is lesser or equal to 80. Second constraint. And x1, the variables, the objective, the decision variables should be x1 and x2 should be a positive, should be the positive values, no negative, which we want. Now the question is, solve the following ADPP by graphical method. How to do? Number one, what do we do here? Let me use some of the point you can understand. Okay, what do we do here? Here we write solution. Don't forget, here we make as a solution. We say solution number one, all right? The solution which are going to solve this one, what do? We convert the inequality, okay, inequality equation into, okay, equality equation. Let me say equality equations, okay, inequality constant, okay, inequality in constant inequality constraints equation into equality constraint. All right, sorry, inequality. Okay, please go, let's go step by step. That's it. This is step number one. Okay, this is step number one. We are going to convert the first, this is a constraint, please keep in mind, this is a constraint. We are going to convert this into equality. How do? We take x1 plus what? 20x2, which is equal to 120. Number two, 8x1 plus what? 8x2, which is equal to 80. Keep in mind, this is equation 1, this is equation 2. This is step number 1. We convert them into equality. Step number 2, what you are going to do is, okay, step number 2 which you are going to do is start from question 1. Start, okay, from what? From equation 1. Start from equation 1, okay, by saying when, okay, when x1 is equal to 0, okay, then, okay, x2 is equal to what? If x1 is equal to 0, then x2 is equal to what? x2 will be equal to what? x2, we find the value of x2. We find the value of x2. I'll repeat again. Here we start from this equation. Let me make it clear so you can understand. This is, we start from this one, okay? This is, we start from equation, okay? We start from equation 1, okay? And we say when x1 is equal to 0, then x2 is equal to what? What is the value of x2? Okay? What should be the value of x2? All right? So for this equation, keep in mind, first equation is 10x1 plus 20x2. Okay? 10x1 plus this one, I don't want it. Okay? I don't want all of them. Now, remember, we are going to solve this 10x1 plus 20x2, which is equal to 120. Now, x1 is equal to 0. Now, we remain with 10, okay, into 0 plus 20 x2 is equal to what? 120. This is 0, right? Now the equation will remain with 20 x2 is equal to what? 120. All right? Now here x2 is equal to what? x2 is equal to 120 divide
60.
20. right? x2 is equal to what? x2 is equal to what is x2 is equal to 6, correct? x2 is equal to 6. So now we find point 1. Point 1 here, for equation, you draw a table here. Let me draw a table here, okay? Let me draw a table, a small table like this. You do it, okay? As I do, you to follow me, okay? Okay, you do follow me. Here we say x1, this is x1, this is x2, okay? If x1 is equal to 0, x2 is equal to 6. Now, come to the second. If x2, when x2 is equal to 0, okay? This is when, we say here when x1 is equal to 0, that's number 1. Here, when x2 is equal to 0. Now, we are going to change there. 10x1 plus what? 20 into 0 is equal to 120. Is equal to 120. It's continuous here. Now, this is 0. 10x1 is equal to what? 10x1 is equal to 120. And x2 is equal to what? 120 divide 10, which is equal to, what is the value? Is equal to, what is the value of x2? x2 is equal to, x2 is equal to 120 by 10 is equal to what? 12. Okay, is equal to 12. Okay, so the value of x2 is equal to 12. Okay, we come here. Remember, you have to cycle every value so that you can remember where they are. Okay, when you cycle them, you know when they are, where they are. If x2 is equal to 0, the value of x1 is equal to, this is x1, sorry, x1, the value of x1 is equal to 12. Correct? This is for equation 1. Okay, this equation 1 known as the line 1. This is first line. Okay, first line. All right. Now remember, we have 0, 6 and 12 and 0. Okay, 0, 6, 12 and 0. Now we plot on this one. We plot on vertical line. Let me use some vertical line so you can have the proper line here. Okay, your line should be straight. Okay, your line should be very, very straight. All right, your line should be straight, so that you can be able to, you use a scale. Okay, for you, you have to use the scale so that you can have, you know, the exact line. All right, so in this one, as you can see, this is going to be, okay, this is going to be x2, this is going to be, sorry, this is going to be, this is gonna be x2, this is x2, sorry, this is going to be x2, okay, this is going to be x1. Okay, now we plot, like, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. You put same distance, same interval. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it would be better if we use like a grid. Okay, if our table is like a grid, maybe I will try to check in another, I will try to bring some paper so that you can see how it works. Now we have the coordinate. These are known as a coordinate. Please keep in mind, these are known as you can see, these are the coordinates. This is known as coordinates. Time is up. Coordinates. Okay, these are the coordinates. All right. So for the first coordinates, we mean when x1 is equal to 0, when x1 is equal to 0, this is a 0, this is a 0, okay? This is a 0, this is a 0. When x1 is equal to 0, then x2 is equal to 6. x2 is equal to 6. This is 1, this is 1, 2, 3, 4, 5, and 6 is equal to 6. This is it, okay? This is it. Next one, when x1 is equal when x2 is equal to 0, then x1 is equal to 12, is equal to 12. x1 is equal x2 is equal to 0, x1 is equal to 12. Where we go? 1, 2, 3, 4, 5, 6, 7, this is 7, 8, 9, 10, 11, and 12 here. Okay, this is equal to 12. x1 is equal to 12 when x2 is equal to 0. Now what do you do here is you are going to join these two lines. We are going to join these two lines. Line off from this line, these 2 points has to be joined. Okay, these 2 points has to be joined. Let me give the line of yellow cannot be clear. Yeah, no problem. All right, this is it. This is the first line. All right, this is the first line. This is the first line. This one you can name this one. You can name this one as a point A. No need for points. This we name as a coordinate. This is a coordinate. When x1 is equal to 0, x2 is equal to 6. Here, when when x1 is equal to 12, x1 is equal to 0. Okay, to 0. This is a 12. Sorry. This is a 12. Okay. This is a 12, and this is a 0. Okay, this is a 0. So these are the coordinates. This is the first line. Second line is going to be for the second equation. All right, second line is going to be for the second equation. For the second equation, as you can see, for the sake of time, as you can see, if x1 is equal to 0, okay, what is the value of x2? x2 is equal to 8, x2 is equal to 100, is equal to 80. All right, now x2 is equal to what? 80 divide 8 is equal to 10. Okay, now you put this one into this table for the second line. This is for the second line. This is x1, this is x2. Okay, and if x1 is equal to 0, now x2 is going to go equal to 10. Okay, same, they have same value. If x2 is equal to 0, now x1 is equal to 10. Okay, 10 means 0, 10, 10, 0. If x1 is equal to 0, come back to this line. I'm going to use group. Let me use a yellow. Yeah, yellow will be okay. Yellow. Okay, but I cannot see where is yellow. Let me use a green. Okay. If x1 is equal to 0, now x2 6, this one 7, this is 7, 8, 9, 10. Okay, 10. All right. If x1 is equal to 0, x2 is equal to 10. Here, 10. This point means the coordinate 0 and 10. Okay, 0 and 10. Now, if x2 is equal to 0, x1 is equal to 10 here. Okay, here we have a 10 and 0. Now we are going to draw this. Line. Let it be, okay, 10, 0, 10, and what? And 10, 0. This is the line. Okay, this is the line. As you can see now. All right, as you can see, This is, which line is this? Which line is this? Is line number, this is line number 2. Okay, this is equation number 2. This one is a first line. First line. Okay. Now, for the next step, I shall explain for the next class, since the time is almost. Okay, time is up. I cannot exceed the time, but I will show you how to shade. Remember, if we have the side eraser done, let's say the constraint which we have here, look our constraint here, look our constraint here. Where is the example? Yes, look our constraint here. We have this constraint which says greater than. Okay, first question, where the shade should be. For the first question, for this first question, where shade should be, above or below?
Below the line.
Is below the line. Good. So the first shade will be below the line. Which first line? This is the first line. Okay. The shade is going to be, let me use the marker, let me use the pen. Okay. Okay. Okay, no problem. It's going to be below the line. It's supposed to be here below the line. Okay, below the line. This is where the shade is supposed to be, below the line. Okay. For the second one also, it has to be below the line. Below the line, below the line, below the line. So for the next class, I shall explain to you how now to find the profit, okay, how to find the maximization objective function, how to plot it. This is how it's supposed to be shaped, but remember, we want to find what should be the maximum or minimum. So we can shade the maximum only, or we can shade the minimum only. That will be done for the next class. If anyone has a question, is it clear? I hope it's clear. Is it clear? Pretty, Serin Rose, Amartavani. Okay. Okay. If it is clear, you can thumbs up. If it is simple, it's very simple. Okay, Amartavani, correct. Good. Aren, correct. Serin Rose, correct. Putur, correct. Next, Panta Banu. I just want to have confirmation from you, okay, so that I will know those who have a difficulties, so that I can. Nisini Rupama, Pretty, Putur, Sonu Kumar, Chaitrapi, okay, Panta, okay, correct, good, good, very good, very good. Induredi, Induredi. So this is the first stage. I will give you what you are going to do. Write down your equation. Sorry. You are going to join next class. Let me give you your equation. Let me check some of the equation for you to be done. No need to give you equation. You have done some of the formulation. Okay, I gave you one of the formulation, but to be very, very, very precise, okay, to be very, very precise, I want you to do this. Hold on, I'm going to give you one equation and you do it, okay? Write down this equation. I'm going to give you this equation and you will solve this one. This should be your your assignment to be done, okay? This assignment is like this. You are going to have max, you are going to have the max, okay, the max z, okay, is equal to 2x1 plus 3x2, okay, subject to constraint. Our subject to constraint is gonna be, okay, 2x1 plus x2 should be lesser or equal to 12, okay, and this is gonna be x1 plus, okay, 3x2 should be lesser or equal to 15, okay, where x1, where x1 comma x2, comma x2 should be greater than 0, okay. This is, please work on it, okay, work on this one. This is your equation, this is comma, okay. This is your assignment, please. You are going to plot this, okay, you are going to plot this on graph, plot it on graph. So for the next class, I will check, you will send to me, I will check, and then we shall discuss how to do the maximization. Next class will be maximization, So we shall find the maximization line. So thank you for joining today's class.
Sir, can you send this PDF to us?
Or which PDF?
This one, sir.
Oh, sure, I will send.
Okay,
I'm
sir.
going to send.
And even from the starting of OR, sir, we didn't receive any PDF for
For the
OR.
first classes, you can mute yourself.
Yes, sir. I'm on mute.
Mute, because I can hear you voice coming. Yeah, thank you. For the first class, what happened is I have explained to you by writing through the PDF. For those who have taken the note, kindly share in the group. I think the first thing which we have done was phases of OR. What should be the phases of OR? Okay, that we have seen advantage you have done as assignment, and we have seen the application of OR you have done things as assignment. So we have done this, we did this one, in a broad way, in a clear way, and I will try to check the PDF where it has been saved so I can send. But meanwhile, I tell Pretty V, please share your note in the group. Okay, share your note in the group. If there is no more question, kindly let's meet tomorrow. Bye bye all.
Sir.
Thank you.